Okay, I think we can start. Hi everyone, I'm Gianmarco, and this guy here is Marco. We are both developers at Iliax, and we are working on Namada. Today we would like to introduce how to basically do some basic operation on Namada, like starting a node, sending some transaction, seeing some logs, those kind of things. But first, we would like to introduce what Namada is. So Namada is a blockchain, is an L1 protocol, and it has a couple of main features. Like it's first based on Tendermint, so we use Tendermint as a consensus layer. And we have a couple of nice features, like we use a proof of stake mechanism with cubic slashing. We have a mass pool, so a multi-asset shielded pool integrated into the protocol. And the last feature is public good funding. So why we think Namada is great and could help some people. First of all, it has the ability to transfer some asset from other chains to Namada, and in a trustless way. So we have a IBC connection with any Cosmos chain, and we also have bridge between Namada and Ethereum, so people can just transfer their token from their chain to ours. And this is very good because then they can shield their tokens into the mass pool. We also have this PGF mechanism through which we are able to give back some, something to the community, because we are also rely on some other projects, so it would be good to give them back something. This is a picture of the team. We took this picture in last year in August. And most of the 50% of these people are now working on Namada, and the other 50% is working instead of Anoma. Adrian just gave a speech about it, but today we are focusing on Namada here. Okay, so we can start with the workshop. You can check the slides at that link if you want to try out some commands without having to, it's easier to copy paste them. Okay, I think we can start. Okay, so first of all, we have to install Namada somehow, and we can do this in different way. The recommended way is always to clone the repo and build the binaries from source, but this takes a lot of time, so we provide some already pre-built binaries we can download. And we provide them for Linux, Mac, and also for the M1 and M2 Macintosh. So we download them. As soon as the download is finished, we can extract them from the archive. Next step is give them permission to be executable binaries. And last step, just for it's better if you do it because it simplifies things a lot, is to put them on your on path, basically. Okay, so we have downloaded, we have set it up. Now let's check if the version of Namada, which is always useful. So you can see the version is correct, and we can proceed with the next step. Next step is installing Tendermint. We use Tendermint, as I said, as a consensus mechanism, so we need to download it. Again, we are providing some binaries. You are free to build them from source, but again, it takes time. Again, we have downloaded them, and now we need to extract the binaries from the archive, give them executable permission, and move them to path again. Okay, so as a last step for this setup, let's check also the Tendermint version. Okay, perfect. So we now have Namada installed, we have Tendermint installed, and let's see what we can do. So we have prepared a network, a small network with 3 validators just for this workshop. We can use this command to join the network. It's going to set up everything locally on your machine. And now you can see that he is downloading all the configuration. But I mean, you can also do it from I mean, you can also do it on your local machine without having to go through this automated process. This is just easier. Okay, so we have set up the node. Let's just run it. Okay, the ledger started. It's now syncing. Most of them are, I mean, empty blocks. So it's pretty fast. Still catching up. Okay, meanwhile the node is catching up, we can check what's in the node folder. You can check where the node folder is based on this path. Either we have different path for Linux or for Macintosh. So let's see. So inside the Macintosh, the OS 6 Namada base folder, we have I mean, a folder and 2 files. This one is just the global config is just used to tell the node which is the current chain ID. Then we have the Genesis file. Okay, this is basically the Genesis file, and this file has been downloaded from the init, the join network command. And from in this file, we can see how the network is configured. We have, for example, the Genesis time, the ticker of the native token, and then you can see that there are 3 validators: validator 1, validator 3, 2, and 1, with their respective keys and commission rate, tokens, staked balance, and other kind of information. We have a section with describing which are the token present at Genesis. So, for example, we have dot and some. I mean, they are just placeholder right now, but this is more or less what it will look like during in mainnet. And then we have some other section, like the parameter section and the post parameter section and the governance parameter section, which describe basically the how these 3 mechanisms are parameterized. For example, in the post parameter, we can see that the maximum validator slot are 128, and so it means that there are only 100. There is a cap on the number of validators for this specific network of 128. What else? Yes, all these parameters are changeable through governance. So everybody, I mean, people can propose to change any of these parameters by sending a proposal, and if 2/3 of the people vote yes, then parameters are changed. Okay, so back to the node, we see that the node is synced. We are at 877. So let's check some of the logs here. You can see the last committed block hash, the height of the last height registered by the node, and then we can also see some more information about how many transactions have been applied in this block. Right now, we didn't send any transactions, so the number of transactions is 0. Okay, so our node is set up and it's running. So let's generate some keys that we need for making some transfers. In Namada, we have two different kind of addresses that can be generated from keys. One, the first type is called implicit, and the second type is called established. So we first are going to generate an implicit one and then an established one. So right now, Marco has just created an implicit address called with an alias, and he gave this address the alias Marco. And using this implicit address, he's going to create an established address. So he's going to basically send a transaction to the ledger, and the ledger is going to register this new account. These are basically the logs of the client, where you can see that the transaction has been accepted into mempool, and in Namada, we have a two-step mechanism for executing transaction. First, the transaction is included into a block, and during the next block is going to be executed. So the changes are going to be applied to the ledger. That's why it takes a little bit, but as you can see at the bottom, the transaction is initialized one new account with that alias and that address. So now if we list all the addresses in our wallet, we can see that Marco has generated two new addresses. One is implicit and one is established, and the one is called Marco and the other one is Marco Est. What's the difference between the two addresses is basically that the implicit addresses are always they don't have custom logic. The only logic they have is that transaction needs to have a valid signature attached and nothing else. And instead, the established address can have custom validation logic. So you can attach like a custom, we call it VP, so like custom condition for your transaction to be executed. For example, you could say, my account will not accept any, I don't know, Ethereum token. So if anybody sends you Ethereums, the transaction will be rejected. And you can choose, your condition on how you want it. So now we have a couple of empty addresses. So let's take some address from the faucet. It's quite easy. We just have to make a transfer from the faucet to one of our established account, and we can specify the token we want. In this case, we want num and how much we want, 1,000. And right now it's limited to 1,000. So if you ask for more, it's going to reject the transaction. Okay, it's transaction has been sent, accepted into mempool. Okay, the transaction has been executed correctly, and we can check the balance using the client balance command. And you can see that our balance is 1,000 right now. You have to make it. So we will get some more num from the faucet because otherwise we don't have enough for the whole workshop. So we just ask for more. Okay, now we have enough token. We have 2,000 nums, and the next step will be so we have seen how to transfer some token from the faucet right now, and right now we want to try to bond some token. So what we can do is we can list all the validators in the current network and with the client bonded stake command. And as you can see, there are 3 validators, and you can also check their stake. and let's try to bond right now. So we can use the bond command, and we specify the source as our established account and the validator to which we want to delegate some token. And also the amount of token we want to stake, delegate. Okay, so the transaction has been executed. We can check with the following command how our delegation. And as you can see, we have delegated 1,001 NAM token to the specified validator. But this token will be, this delegation will be active only from epoch 30. And right now we are in epoch 28, so we probably have to wait a little bit for them to become active. So right now we can also try to make a transfer between two account, and you guys can also try if you want. You can share between yourself your address and try to send some NAM to each other. So right now, Marco is trying to, what he's trying to do is trying to send some of the NAM he got from the faucet, from his established account to his implicit account, and is going to transfer 10 Namada token. Oh, okay, so now if you query the balance of the implicit. Okay, and now if you query the account of the implicit, the balance of the implicit account, you can see that 10 NAM has been transferred. But so right now we have just seen like transfer, like the transparent transfer. But in Namada, users have also the opportunity to transfer them using the multi-asset shielded pool. And so right now we're going to show you how you can do it. First of all, you need to create a MASP key, which you can do with the following command. Okay, so we have a key. Let's see if what the wallet says. And you can see from the wallet the key has been registered. Now we have generated a key, a MASP key, and now we need to generate a MASP payment address to receive to make transfer. Okay, we have generated the payment address, and now let's see what the wallet is saying. The wallet, has created the address. And now let's try to transfer some Namada from our established account to our MASP payment address, so that we can transfer them from the transparent Namada to the shielded Namada, let's say. We basically, for transfer, we are using always the same command. You just have to choose a different source. It's missing the two. We are always using the same command for source. We just the Namada client will just parse the source and target and understand if he needs to shield it or not. Okay, so the transaction has been executed. Let's see if we have some okay, this is our established address, and let's see also if we have some received the token into our MASP account address. Okay, and as you can see now, we have shielded 70 num, so it means that they are inside the MASP pool, and yeah, shielded from anyone, for anyone. Okay, last thing that we wanted to show is how to interact with governance. Okay, so for governance, in Namada, governance is divided into three. I mean, governance has three type of governance proposal. We have the basic governance proposal where people can propose either soft fork or hard fork, and they can propose like a soft fork or a parameter upgrade by attaching to the proposal a WASM code. And if the proposal passes, the WASM gets executed, and so you can change arbitrary things in storage. For example, also the parameters. The other two type of proposal are the Ethereum proposal, where you can change parameters from Namada to the Ethereum smart contract. And the other one instead is the PGF proposal, where PGF stewards can be elected, and people can vote if a specific PGF proposal is valid or not. So right now we cannot show you on the ledger directly on the ledger how governance works, because we don't have any proposal active, and to send a proposal, we need like, I think 3 or 4 epochs to pass. So it's kind of time consuming. But basically what you can do is, we have mostly 3 important commands to remember. One is the query proposal, which gives you a list of all the active and inactive and pending proposal. In Namada. Right now there are none, so it shows anything. Then we have the init proposal command. And the init proposal command gives you the ability to create a new proposal, and proposal can be made by anyone. You just have to pay, you don't have to pay, you have to lock a specific amount of funds, and for this chain, I think it's 500 num, and the funds are locked until the end of the proposal, and if the proposal passes, then the locked amount is refunded to the author of the proposal. Instead, if it doesn't pass, the token are just burned. And to create a new proposal, you just have to create a JSON file in which you describe all your motivation for your proposal, and why and what do you think? Why do you think your proposal is good? And those kind of things. We are following the same structure of as Bitcoin proposal, so BIP. And you just basically send to the client this JSON formatted in the correct way, and then the client is taking care of parsing the JSON and submitting it to the ledger to be included in the storage. After a proposal has been made, if you want to vote it, right now we decided that only people who have a stake in Namada should be able to vote on governance proposal. So if you're a delegator or validator, you are able to make a vote. And making a vote is quite easy. You just have to use the vote proposal command. You just give it which proposal you want to vote, and either yay or nay if you want. Either yay if you want it to pass, or nay if you don't want. Yeah, and this is pretty much all. To wrap everything up, we basically today what we have seen what Namada is, why we think Namada is important. We have seen how to run a node, how to read the logs of this node. We have seen which kind of files a node downloads to set up a node, to set up itself. We have seen how to use the wallet, both for creating MASP keys and creating like transparent keys. We have made some transfer both to the shielded pool and non to the shielded pool. We have seen a little bit of governance, and we have seen also how to delegate to some token into the proof of stake system. So thank you, everyone. If you have questions, you can either ask us later, or you can go to docs.namada.net. Make sure to also check out our social links on Twitter and Discord. And if you're interested, you can always go to GitHub, Namada, and check out, the code, the issues, and pull request, or maybe make your own pull request. Thank you. So anybody has a question? Questions? No questions? Okay, good enough. Thank you.